Hi, welcome back to the Grafana Alloy for Beginner series. I'm Jung, a staff developer advocate here at Grafana. Last time, we explored how to collect, process, and export infrastructure logs with Alloy. Today, we're diving into building a pipeline for infrastructure metrics. Now, each episode builds on the last. Before starting this section, make sure you've watched episodes 1 through 5 and completed section 1 of the Alloy config. Today, we're introducing how to perform service discovery using Alloy. When we're monitoring infrastructure or applications, we're often working in dynamic environments where things are constantly changing. There could be thousands of servers or containers starting and stopping, whose names and addresses are constantly changing. We want to avoid keeping up with ever-changing list of sources that we need to collect telemetry from. But what if we don't need to hard-code all the names and addresses of all the telemetry sources? What if there was a system that automatically tracked all the telemetry sources in our environment, and Alloy could query it to discover what to collect from? That's exactly what service discovery components do. They're configured to query systems like the Kubernetes API or AWEC2, which already track your infrastructure. Then they retrieve and format the list of discovered targets, exposing them to other Alloy components to collect telemetry from. In our learning environment, there's an HTTP endpoint that lists the telemetry sources or targets in our infrastructure. These include backends like Loki, Tempo, Mimir, and Pyroscope, which expose the metrics we want to collect. We'll use the discovery.http component to query that endpoint and discover those targets. Then we'll use prometheus.scrape to scrape their metrics and prometheus.remotewrite to send those metrics to Mimir, Grafana's Prometheus compatible backend. To get started, open the series repo and scroll down to section 2, Build a Pipeline for Infrastructure Metrics with Alloy Part 1. Now, a quick refresher from last time. Each section kicks off with starter code, followed by tasks that explain what the config does and what you'll need to know. Then there's a solution where you can peek at the finished config. For this episode, I'll just walk you through the final config to keep things short. Feel free to copy the starter code into your config.alloy, give it a go yourself, then check the solution to see how you did. Now, if you haven't already, start up your learning environment and open the config.alloy file. All right, you can see mine on the screen. First, we'll use the discovery.http component to find the infrastructure targets we want to scrape. Now, earlier we mentioned that there's a service that exposes those targets for us. This HTTP endpoint is aware of all instances of Loki, Tempo, Mimir, and Pyroscope databases that are currently running in our environment. This endpoint is included in the repo. You can copy and paste the URL here. Next, we set the refresh interval to 2 seconds just for demo purposes. Next, we'll use prometheus.scrape to scrape metrics from the targets we just discovered. We set both the scrape interval and scrape timeout to 2 seconds for this demo. Then under targets, we'll point to the targets of the discovery.http.service discovery component that we just defined. Finally, we'll use a forward-to argument to send the scrape metrics to the receiver of the prometheus.remotewrite.mimir component that we'll define next. Okay, let's configure the last component. We'll use this component to export the scrape metrics to our locally running Mimir. To do so, it's very similar to what we did in the last episode. We'll use an endpoint block and set the URL to the destination that we want to send scrape metrics to. Now, the URL to Mimir is included in the repo, so you can copy and paste it here. All right, we just wrapped up section 2, where we use the discovery.http component to query an endpoint to discover targets to scrape from. Then we set up the prometheus.scrape component to scrape metrics from those targets. Finally, we use the prometheus.remotewrite component to export the metrics to Mimir. Now, if you're configuring your Alloy instance as you watch this video, don't forget to check the solutions in the series repo. As always, reload the config after making any updates to config.alloy. Now, this command is included in your repo. make sure that you see the config reloaded message before you move forward. Let's go back to the series repo and scroll down to the verification section. Click on the link to the dashboard and select the Section 2 verification dashboard. Here you can see metrics coming in from our discovered targets: Loki, Mimir, Pyroscope, and Tempo. Now you should see a value of 1 for each database. This means that they're being successfully scraped. If you see a 0, that indicates that there's been an error somewhere. In this episode, we learned how to discover, scrape, and export infrastructure metrics with Alloy. Next up, we'll go even further and learn how to expose, scrape, process, and export infrastructure metrics. Thank you for watching, and I'll see you in the next episode.